Okay, here we go. Remember the equation of a straight line, y equals mx plus c. M stands in for gradient, and c is where we cross the y-axis, the y-intercept. So we want an equation for this line. Well, the y-intercept bit is really easy. It crosses the y-axis over here at 3. So I know that c equals 3. Now to find the gradient, gradient equals rise over run. Another way to think about this for a line that's going downhill, like this one is as the fall over the run, and it's going to be minus to show that it's going downhill. Now to work this out, we need to pick 2 points and draw a triangle between them. We want them to be a decent distance away so we get a nice clear picture. But most importantly, we're looking for points where we clearly cross over and we can identify the numbers. So I'm going to use this triangle over here. We can see that our run is 2. Not because there's 2 squares, but because each of those squares represents 1 unit. Always pay attention to the scale. So we're going to have over here 2 across and 1, 2, 3, 4 down. So my fall is 4, my run is 2, it's minus because it's going downhill. The answer is minus 2 for the gradient. M equals minus 2. So with these 2 bits of information, I can now say y equals mx plus c becomes y equals minus 2x plus 3. And that's my answer. Now it asks me to draw another straight line in the diagram that passes through 1, minus 1, 1, and is parallel to this line. Parallel means it's going in the same direction. It means it has the same gradient. So let me find the point minus 1, 1, which is here. Now if it's parallel, then it will also have this 2 across 4 down thing going on. So I'm going to just quickly sketch that out. 2 across, 1, 2 across, and then 1, 2, 3, 4 down. So my line would go from this point to this point, and we would now take a ruler and draw a line very carefully through those points and out the other side of the page. And there's that one. So now we want to find another equation of another line. Once again, remember that m stands for gradient and c stands for y-intercept. We can see on this picture very clearly that c must equal 2 because it crosses the y-axis at 2. To find the gradient, I need to draw a gradient triangle, and I'm looking for points on the graph where I can clearly identify where it's going. This thing has a run of 4, paying attention to the scale, and a rise of 2. Okay, 1, 2. Pay attention to your scale just in case it's different. So my gradient is rise over run. And in this case, the rise over run is 2 over 4, which is a half, 0.5. Don't just divide the big number by the small number. Look for which one is the rise and which one is the run, and divide rise over run. This answer is positive because the thing is going uphill. In our previous question, we made it negative because it was going downhill. So now I can say y equals m, the gradient, 0.5 x, plus c plus 2. And don't be too worried about why this is true. As far as we're concerned, this is just a rule that we are using, and then we get marks for it. Here's another one. I want to find the gradient of the line AB. Now, Once again, I want to pick points where I can see clearly where it's going. I'm going to pick this point down here because that one seems pretty clear. And this point over here looks pretty good as well. Or I could go all the way up to the top over here for B. It really doesn't matter as long as you can see the points clearly and they're not too close together. I'm going to use these two. Now here we have to pay a bit more attention to our scale. So here's my gradient triangle. We can see that the run down here is just 1 unit. And the rise takes me from 1 to 2 to 3 to 4. So I've risen 3. 1, 2, 3. So my rise over my run, my gradient, oh dear. My rise over my run is equal to 3 over 1, which is just 3. And that's my first mark. And that's it for this question. So now we've got some formulas we have to make different letters to subject, and I'm going to address that in the next video.